If you would have told me 18 months ago that we would have Randy come and speak from Canada about an extremely important topic, even more so than what some people thought, let's say 2 years ago, I would not have believed you. Okay. I'm just going to introduce very informally Mr. Randy Freeborn. Because you guys must have read his bio, which is very long. I'm just going to say, for those people who are not very familiar with what SPE Distinguished Lecturer is, by the way, SPE, Society of Petroleum Engineers, there are only 30 people out of 143,000 members who are actually distinguished lecturers. Okay. On top of that, it happens that Randy is one of those 30 who understands mathematics. Okay, so he's really part of an elite. I would say as well that his topic is extremely relevant and timely, and is part of our Reserve and Resources series we started 5 months ago. Okay, so it just makes I think total sense that he would speak about shale economics, about I would say type wells, about the forecasts which are stemming out of these wells. Basically, I'm very pleased. I'm very pleased, and that's just the way it's gonna be. Okay. I will say this as well. I mean, Randy is going to speak a little bit about Energy Navigator as well. I think these guys have done a great job. They have a great team as well. Dr. John Lee is part of their team. He's not going to be here today, but he told me he would have liked to come, so that's good enough for me. Okay, in the sense that it's just some kind of a testament of all the hard work some of us have been doing, starting out of nothing 18 months ago. So without further ado, thank you so much, Randy. Okay, and give him a round of applause if you want, to make sure he does a good job.
Does this echo at the back, or should I just speak without it?
No, it's okay. Speak with it.
It's okay?
Yeah.
Okay. I only have 3 slides of advertising to tell a little bit about who Energy Navigator is. We were founded about 20 years ago. We have offices in Calgary, Houston, Denver, and we're just this year opened an office in Brisbane. So we are not just a local Canadian company. We have 2 products, one that we call ValNav, Value Navigator. That's reserve economics and forecasting software. And we have currently about 300 users of that software. It includes E&P companies, virtually all of the Canadian banks, all of the Canadian reserve houses use our software, and we are we have the dominant market share in Canada, and we're slowly breaking into the US market. We have another software package called AFE Navigator that lets you steward and navigate your AFEs from gathering up the data to getting approvals to sending it out to partners, the whole works. And so AFE, even in the US, is a very well-known and well-recognized piece of software. So that's who we are. Our commitment, we want to be a partner with our clients, not a vendor. And so all of the things that we do because our clients ask for them. We have 30 developers and testers on staff developing, so we are actively working at adding new products and new functionality every year for you to use. In addition, we want to be a knowledge leader. We reinvest money into research. 10% of our revenue goes back into research, and that's research that we share with you as operators, whether you're clients or not. That's sending me to give talks like this, or presenting, or doing new and original research, some of which you'll see tonight. And we have published white papers on our website if you want to follow more of the things that we're working on. And we can't do that without having some experts. And so we have about 8 experts on staff that we would call experts, but these are the prominent ones. You probably all have heard of Dr. Lee and Rod Seidel. Dr. Lee is at Texas A&M, professor there. He's probably taught all of the engineers in Texas at one time or another. Rod Seidel is ex-Shell, and he is a reserve expert and is providing advice to us on reserve administration and how we need to develop our software to handle your needs in terms of reserves. And then there's me, of course, and Boyd Russell, our president. 3 of those are distinguished lecturers, by the way. So we have a very high caliber of technical staff helping us to solve your problems for you. And that's the end of the commercial. So,
it's worth pointing out that there are some technical brochures over here.
Sure, there's some brochures over there. I've left my card there, and Bill Agee has as well. A big hand for Bill Agee for buying all the pizza tonight.
Oh, yeah.
Yes, and I'm available anytime, so if you've got questions or want to email me, grab a card and send it, and I will guarantee that you'll get an answer. So I've broken the talk into 2 parts, one on type wells, and this is essentially my distinguished lecture talk with a few additions. And then there'll be a second talk on top of this, which will deal with a brand new way of forecasting that is just in the research stage now. So you're the first to see this, or maybe the second. If you've got questions, it's much more fun to answer questions on the fly rather than wait for an hour and then what did I want to ask and I can't remember. So if you've got a question, please raise your hand and ask it. Talk loud enough so that everyone can hear your question. And let's do it that way. If I start running out of time, then maybe we'll say let's hold the questions a bit. So this is what we're going to talk about with type wells. First of all, what is a type well? And what challenges do we have with type wells? I'm going to show you 3 inherent errors with the way that we create type wells. And whether you're an engineer that's creating type wells, or whether you're somebody that uses type wells, you need to know this. You need to know what questions should you be asking when somebody shows you a type well. And then I'll switch from just averaging to how we create probability type wells and what problems and solutions we have for how to create probabilistic type wells. So that's the type well agenda. So a type well really simply is just a rate time production profile. Usually it's created by averaging wells, but it doesn't have to be. It could be created through a rate time analysis program. It could be created from a reservoir simulator. It's just a rate time production profile, but normally it's created by averaging wells that are relevant and make sense to what you're planning to drill. I'm not going to go into getting the right wells and what do you do if you don't have enough wells. I'm just going to talk about the process of creating a type well. Normally what we do is we average the production data for the wells that we have data to average. So why wouldn't you have data to average? Well, maybe a well's a newer well because we shift these all to start at the same time. So maybe a well hasn't produced long enough, or maybe it's depleted, and we no longer have data to average. So we average the wells that we have data to average and create a historical portion of a type curve. And then we run a decline through that, or a best fit forecast, to complete the rate time profile for our type well. This is what everybody does. It's done with history only. So why is this a problem? First of all, the use of type wells is pervasive. It occurs in all aspects of our business, from designing facilities to drilling wells to talking to bankers. It's used everywhere. And it's used not just on normal projects, it's used on big dollar, capital intensive projects. And if you're wrong, it's either you're going to be out of a job or you might be out of a job no matter what. And the issue is that there's errors in how we create those type wells. So who has experienced these errors? Dr. Lee reports when he was working with the SEC modernizing their rules. That was about 2008. The SEC's opinion was that in all the type wells they see, typically they're about 25% high. They're overstating. There was a recent study issued out of Canada, a company called ITG, 2013. They looked at drilling results from companies that published their type wells. And they looked at 100 type wells, or 100 plays rather. And out of those 100 plays, only 40 of those plays achieved the target. So they looked at the type wells, and then they looked at the drilling program for the next year or two following those type wells. And most of the time, they did not achieve the objectives. And only 14 of those 40 companies studied really met their targets consistently. Now, I build a lot of type wells because I'm Mr. Type Well. And my personal experience is your EUR is more likely to be overestimated than underestimated when you build your type well. And I've seen as much as about 40%. My boss or colleague, Boyd, would say it's probably 50%, but it's a big number. So let's look at these three inherent errors one by one. I'll describe them and then I'll show you some examples. The first is forecasting from groups. What do I mean by that? Is when we average the history only and then forecast out of it, we're lumping the production and then we're forecasting from that lumped production. The second is something called survivor bias. And in our industry, survivor bias is traditionally, well, actually Wiki says it's concentrating on things that survive and ignoring the things that don't survive. In our industry, that's normally related to depleted wells. How do we handle depleted wells? And the real answer is we have to assume a depleted well is continuing to produce at a rate of 0. And if you do that, things will work out right. We'll see why it doesn't work out right. The other problem is a declining well count. Wells that run out of production and how we treat the wells that run out of production. This is also a form of survivor bias because there's no production, we ignore those. But it's not something as an industry that we would call survivor bias. So let's look at the first inherent error, forecasting from groups. Here I've taken 9 wells that have 27 years of production history. And I've taken the first 8 years to build a type well. Normally, we don't see a nice clear trend like you see here. Normally, we can't find a trend, or worse, we'll find more than one trend and we're not sure which one to pick. In this case, we've got a good trend that we could forecast from, and we probably say that's a great forecast. So what happens when we add in the additional 19 years? And this has not been cherry-picked. We see this happen all the time. This, by the way, is some Hugoton gas wells, they're vertical wells, but they're fractured. And so I'm just looking at, and they're shallow.
Question. So just so I'm clear, because I'm kind of learning these things, okay? When you're grouping those wells, how are they being combined? Is it straight average, a weighted average?
Yeah, I'm time shifting the wells so that they all start at the same
Right, I
date,
understand.
and then it's a simple average
Okay.
of the wells that have data. So here's the other 19 years of data. We really would have made a bad business decision had we acted on the type well that we created here from group to production. If you look at this extra 19 years carefully, you can see that there was a trend falling off about 2 years back. Every dot is a month. So it was there, we just didn't see it when we grouped the data. And so we missed it. So what we recommend is group your forecasts. In other words, for every one of your wells, forecast your wells, and then average both the history and the forecast as though that you knew everything. And in yellow, that's the type well that would result from this data. Now remember, I have full data through here, so I'm forecasting these wells with 8 years of history, so I've got a lot of history to forecast from. My expectation is every one of those forecasts will be wrong. But we have statistics working for us. For every well that's wrong high, there's probably another well that's wrong low. And we'll get an averaging effect, and the errors will tend to cancel one another out, leaving you with an overall better forecast, and we can see that in the results. Now, I've heard people say, well, we can't forecast our individual wells and use that forecast to create a type well. And my answer would be, well, why can't you? Because you're doing the same thing. You're averaging them up and forecasting out. Isn't that the same thing? And the answer is yes, it is. But this is going to get you a much better answer. So what we're seeing is, in terms of solving this problem, we should use history and forecast when we build our type wells. So let's look at survivor bias from a depleted well perspective. So here we've got a well that's depleted, and we change from averaging 3 wells to averaging 2, because we average the wells that have data to average. We can show mathematically that what's happening is that when we use this type well to drill wells, what we're actually doing is assuming that this depleted well continues to produce at the type well rate, at the average rate of your type wells. And I'll show you some numbers on that to confirm that for you, because some people just, it's a difficult concept to understand, and I'll explain that a bit more. But it's worse than what you see, because what happens if you have a bunch of depleted wells? Then what happens is every time you have a depleted well, the rate bumps up. So that this is the historical portion. So now when we predict the rest of the well, we're starting at a rate that's too high, and we're starting with something that has some curve in it that didn't have some curve in it before. And so we've got two things working to cause us to overstate the EUR with this type well where we have depleted wells. So what happens if it's not a depleted well? What happens if it's just a well that hasn't produced long enough to have data to average? Well, normally when we drill our wells, what do? We drill a few wells, and very quickly we try to find out where the sweet spots are. And then we drill our best wells first, and our not so best wells later. So what happens when we do that? This well here that runs out of production first, your worst well gets the type well rate, which is the average rate from all of the wells that were drilled sooner, all of the better wells. So We may not expect to get the same increase or bump in the rate because of this averaging process we're doing, but it will happen more often because we're always drilling wells month after month after month. And so every month our well count is dropping, and that causes that compounding effect to occur. But because it's so uniform, you don't see it's happening. So here's the simple example, and I've just extracted and I've made up the numbers. They're not coming off the graph, I've just made them up. So we're going to build a type well using 3 wells. 1, 2, 3, and here's the field total for those wells. Our type well rate will be the field total divided by 3 wells until we have a well that runs out of production. Then the type well rate is the field production divided by 2. And so there's our type well rate that we have from these 3 wells. Now, how do we use a type well when we're going to drill a new program? So let's assume we're going to drill 3 wells. Do we take our type well and say, well, here's our type well, let's multiply by 3 wells, but only do that for the first 10 months, and then let's change it and multiply by 2 because I know we've got some wells falling off. We don't do that. We just multiply our type well by 3 for every month. So the first 2 months we're okay because we're multiplying by 3 and we divide it by 3. But here we're multiplying by 3, but we divide it by 2. And if you look at the difference between the field rate from the wells that we used to build our type well to the field rate from the wells that we're going to drill using this type well, the difference is the type well rate. And so that's a numerical example, what I'm describing in terms of what happens when we drop the well count when we build our type wells. And so here's an example. This is the same Hugoton field, but now I'm using 88 wells. So I've bumped up the number of wells I'm looking at. I took 5-year drilling program. So I said, over 5 years, we're going to drill these 88 wells, and then we're going to add another 5 years of production data. So when we're forecasting our wells, some wells will have 5 years, some wells with 6, 7, up to 10 years of data. So 5 to 10 years of data that we're doing our forecasting. Normally, if you're using history only, we use a cutoff. So everyone recognizes that there's a problem, and so they say, well, we're going to solve the problem. We'll stop averaging when fewer than, in this case, 75% of the wells have data to average. We're going to stop, because if we don't stop, then we're going to get this problem with the shape on our type well. But in reality, that just says 25% of the wells have been falling off and creating this curvature and creating a problem for you when you build your type well. But again, we end up with a type well rate that looks really, really straight. I mean, who wouldn't think this is an awesome type well? Well, the answers would suggest it's not. I'm going to show on the next slide this same curve here, and I'm going to show you a big yellow band that brackets that, assuming we run a 50% cutoff, 75, and 100% cutoff. In other words, there's no wells falling off. And so there's that band here, and here's the real production numbers from 88 wells now. And how good did we do? Well, we're out by about 30. Let's just do with the cutoff. The known answer is 1.36 BCF, and we could be as high as an extra 28% building our type well if we used a 50% cutoff, to as low as 13%, building our type well using history only. Let's find out what happens if we use history and prediction. So we forecast all 88 wells and build our type well. We don't have quite a known answer because these wells are still producing, but even out to 25 years, we've got a really, really good type well. So, does this happen just for the Hugoton field, or does it happen elsewhere? So I picked a Canadian example. This is a heavy oil over water, so it's a water toning example. And in this case, all of the wells that I'm showing you are depleted. So here's what happens if I have a 75, sorry, I'll back up. Again, we've taken a 5-year drilling program, so over 5 years we're drilling our wells, and in this case, we added 1 more year of data. And we forecast using a 70% cutoff. And that's, the dots are the real data, and the yellow is the projection of the forecast using that data. So then we switch to a 50% cutoff. And all of a sudden now we're getting some extra bump in here, and we're predicting a different recovery. Now what happens if I use history and forecast to predict? And that's what I get using history and forecast. And if we put it all together, you can see 70% cutoff, 50% cutoff, and that's the right answer. And so in this case, we're under-predicting when we use history and history only. So now let's look at this and say, oh, I think I got 1 more button here. What happens if we add 1 more year of data? Just 1 more year of data. What does it look like? Well, now we're starting to see some curve in this data. And so we're looking at a hyperbolic type fit. We switched to 50% cutoff. And now we've got even more hyperbolics because we're fitting a narrower range here and project outwards. And here's what we get using history and prediction. And we show it all together. And that's what it looks like with an extra year of data. And if we put it all together, we see that with or without that extra year of data, we're still doing a great job of predicting the EUR. Our type well is matching the data very well. But the whole idea that this thing can flip to either side based on how much data you have is just really scary from my perspective. So that's the 3 inherent errors, and every one of these errors can be resolved by forecasting each of your wells and then averaging both the history and the forecast for those wells. Now I'm going to switch topics to probabilistic forecasts. I don't know that probabilistic forecasts are used as much in the US as in Canada, but I think they should be. So here's some questions. Somebody gives you a type well. What do you need to know about that type well? Normally, they'll just say, here's my type well. It's published in a press release, or somebody's giving you the type well and say, use this to run the economics, or whatever. What do you need to know? First of all, what's the certainty? Is this a P90 type well, a P10? What level of certainty does it represent? What's uncertain? Usually, type wells are created as EUR, and it'll be gas or it'll be oil. Sometimes you'll see BOEs. But I'm going to suggest maybe a paradigm shift that it doesn't have to be EUR. It could be NPV. It could be what fraction of your CapEx do you recover in the first 2 years? Is this a self-financing project or not? How many wells does it represent? Does this represent drilling 1 well or 10 wells or 50 wells? All of those will give you different type wells that I'll show you. And what's the intended purpose? Maybe your purpose wasn't to defend reserves. Maybe it was to look at economics or something else. So let's look at the different ways that we can use to build a probabilistic type well. The first is one that I call a selected well method. We made it up because at the time we wrote our first paper, nobody really had a method to create probabilistic type wells. And so our suggestion then was, if I want a P90 reserve, and I'm going to drill 50 wells, then I can go to monograph 3, which will show me the uplift that I need for drilling the 50 wells, and I'll talk about that a little bit more. But I can find out what the probability I really need to look for, and then I will find some wells that balance that, because I'd like to see some averaging effect. And I simply average that subset of my overall probability distribution, and that becomes my P90 type well, or whatever that you're looking for. You'll notice on the bottom I have an uncertain parameter. In other words, it doesn't have to be EUR. I think the issue with the selected well method is that we will definitely get the right EUR or the right uncertain parameter, because we're forcing that. We're averaging wells that will yield that number. But in reality, when we go drill some wells, we're not necessarily going to just drill wells that look like this. We're going to drill and get whatever we get. So while we get the right EUR, we might not get, and we probably won't get, the right rate time profile. Where this comes into effect, when you drill a well, basically you've drilled it off of your type well. Then 3 months later, you've got 3 or 4 months of production data. You've got more information. You know that the rate is different than your type well. You may see some curvature if you've got 6 or 7 months of data. And so you may want to have a range of production shapes that you can line up with your production to use that to help you forecast. At Energy Navigator, we call that analog forecasting, and we have a paper on that. If you want, email me and I'll send you the paper. But that's all I'm going to talk about. So this is a fit for purpose. When I said, what's the purpose of your type well? If it's to do analog forecasting, then you might want to choose the B value, for instance, as your uncertain parameter, so that you're actually developing wells with different shapes. And I've talked about all of this, so I won't talk about more. The time slice method is the method that virtually every piece of public domain software uses to generate type wells. If you think about, how do I know that this method has been used to create a type well? There's a couple of triggers. First of all, you're going to push a magic button and automatically the program will give you a P10, P50, and P90 type well. That's one of the first signs. The second sign is it only uses historical data. Now, why does it only use historical data? Well, it's simple. The people that do this don't have forecasts for all the wells. It's really hard for them to get a forecast. So they need to rely on a method that doesn't use a forecast. The next thing that you'll see is when you look at one of these plots here with all the wells superimposed on it, you'll see that your type well actually follows the plot. So you'll have wells that run out of production, but you'll see the type well starting to follow along the wells that remain. They're tracking the more current wells, not the wells that are shown. So how does this method work? For each month, let's take month 1. We take all the production rates for month 1 and we put them in a spreadsheet or in the software, and it sorts all the production data in ascending or descending order. And if you want a P90 type well, it's going to pick the well that's in the P90 position, and that will be the rate for month 1. And then it'll repeat the process for month 2 and month 3, gradually building up this historical data for your type well, from which at some point in time there's not enough data to continue, so they'll run a cutoff the same, and then they'll forecast from that group and create the balance of the rate time profile for that well. So that's what I call the time slice method. So what do we know about this? First of all, you give this to your manager, or you're the manager, and what's the first question you ask? This is a P90 type well. P90 of what? What does the probability represent? It's not EUR, it's not IP, it's not anything that requires more than 1 month of data. You don't know what the probability is. And you may be wanting to drill 100 wells and do some aggregation calculations, but to do aggregation calculations, you need to have a probability distribution. And if we don't know the probability of what, we can't do a probability distribution. So this method technically should only work for drilling 1 well, which we never do, unless it's a pilot that fails. So I've taken each of these wells and I've forecast them out. And I said, well, what's that telling me? So I plot against the original distribution of EUR from each of those wells, because I've now just forecast them and I can do a probability distribution. What's the EUR? Well, the P10's too high, the P90's too low, the P50's too high, and there's some path between them, but we don't know what that path is, and we certainly don't have a log normal distribution. That's a straight line on this probability distribution curve. We're no longer starting with or have the same distribution that we should have. So then I said, every month we're going to pick a rate from a well, or maybe we'll interpolate and that rate will be from 2 wells. So which wells got picked? From which wells did we pick a rate? And every time we picked a rate from a well or interpolated between 2 wells, I colored the dots red. So we built a P90 type well, and we took rates from virtually every well in the sample. 96% of the wells were used to create the P90 type well. So when we look at this rate cluster diagram, you'll see that it's just a big blob of data. Well, it's a blob of data because these curves aren't parallel to one another. They're crossing all over the place. And that crossing has a serious impact that I'd like to show you with a 9-well example. So 9 wells, because when we calculate probability, we divide by the rank. So well number 1 divided by the number of wells plus 1. So I have a P10 well and I have a P90 well. So I know what the EUR should be. So I take about the first 30 months of data to just describe what's happening. And the inside, the yellow bars represent the P10 and the P90 well. P10's the higher, P90's the lower. But if I'm sampling 9 wells in any given month, the P10 rate will be the highest rate that ever got produced that month. And the P90 will be the lowest rate that ever got produced. And so that is the orange bars on the top and the bottom. And in blue is all the places that we have reported a rate that's lower than the P90 or a rate that's higher than the P10. So what's happened is we've got this, I'm going to throw this down for a minute. We've got this distribution of type wells, and what we've done is we've spread that distribution out. And it doesn't matter whether it's 9 wells or 99 wells, that distribution is going to get spread out. So we have, go back to the cartoon, no wonder the P10 is too high and the P90 is too low. We're spreading these curves. And if the P10 and P90 have spread out, that means our type well is inferring a much greater risk, because our risk is the difference between P10 or the P90. Our type well is inferring a much greater risk than we should infer from our type well. So if I put it all together for the time slice method, probability of what? We can't choose a value, and even if we could, it wouldn't spit that value back to us. It doesn't match the EUR that we're looking for. And it's prone to error. All of the errors that we talked about from averaging also appear with a time slice well, but they appear in slightly different ways. We have the issue of cross-rate time profiles, rates selected from all wells. My colleagues calls that a Franken well. That our type well is a Franken well because it's sort of grabbing data from everywhere. And it really doesn't represent a defined group of wells. In reality, we'll drill a wide range, but that's not what this is reflecting. This is reflecting the vagaries of downtime and flush production, bouncing the rates around that destroy the meaning of your type well. So if that doesn't work, the selected wells don't work, how are you supposed to build your type wells? And that's this next section here, something I call aggregation type wells. And it's coming out in our next release, by the way. It's working in a demonstratable fashion. So we have 4 questions when we build a type well. What wells should we build? We've got a whole long list of wells. Should we use all the wells to build a type well or some of them? And should they have equal weighting or should some wells be weighted higher than other wells? And how do I account for the size of my drilling program that I'm going to use this type well for? And how do I get the right probabilities? The answer, we believe, is to calculate an appropriate weighting factor for every one of the wells and use that weighting factor when we do the averaging. Now, I've talked a little bit about aggregation, but I haven't shown you what it is, and some of you may not have seen aggregation before. I'm expecting most of you have not. And so what does aggregation mean? Aggregation 101. We start with a probability distribution, the white line, and every dot on that distribution represents the value for a single well. When we do an aggregated probability distribution, every dot on the line represents the average of a number of wells. So if I were going to drill 5 wells, for example, then every dot on my aggregated probability distribution would be the average from 5 wells. So how do I do this? We use something called Monte Carlo, which is technobabble for picking random numbers. So we pick 5 random probabilities, and then at each of those probabilities we find out what the EUR is from our distribution. In this case, NPV, but I'm going to switch back and forth to show you that it doesn't matter which. And we average that EUR or NPV, and that average of the 5 wells becomes a single point on the aggregated probability distribution curve. So here's the aggregated probability. We repeat that 5 well selection a lot of times, in this case 100,000 times. And the yellow line is the aggregated probability distribution. So why is it steeper? Why at P90 is it higher than drilling a single well? Well, if you think about it, just from a logic perspective, if I'm going to drill 5 wells, will I get 5 P90 wells? Of course, the answer is no. Will I get 5 wells that are as good as or less than the P90? Not likely, because I'm on the low end of the distribution. It's more likely that I'm going to drill some higher EUR wells than P90. And so as I drill more wells, I expect to get a higher EUR on average. But from the P10 side, it's not likely I'm going to drill 5 P10 wells either. It's likely that because I'm on the high side, I'm going to drill less. And so it works both ways, but overall it steepens the line, which means your P10 to P90 ratio is smaller. It means that the difference between the two, which is the uncertainty of what you will get, gets smaller. And so you have a more certain answer from your type well. The other thing that happens is because this is increasing as we drill more wells, if we had wells that were uneconomic, drilling one well, by drilling more wells, we may be able to get to positive economics and now be able to book PUDs for those wells by committing to drill more than if we chose to just do this with one well. So aggregation is a pretty important concept when you're looking at reserves or defending a drilling program. So once we know what an aggregated probability distribution curve is, how do we build an aggregated type well? If I want P90, I know that I'm looking for, in this case, 237,000 barrels. So just like I kept drilling 5 wells before, over and over again, I keep doing that. Except every time I find 5 wells that have an average EUR that's equal to what I'm looking for, the 237, I'll do a running tally of that. So what does that mean? I basically start with this tally that's 0 for every well. So the first 5 wells that I get that match, I'll put a 1 where those 5 wells are. And then I keep doing a bunch more samples, and then I get another one that's 237 or close to, and then I'll tally those. So if I had a well here and it was previously 1, it'll become 2. And if I had a well here that's 0, it'll become 1. And I just do a running total for the number of times that wells were selected that satisfied the EUR that I'm looking for that probability. In other words, if I'm going to drill 5 wells, what's the likelihood that each well would be drilled within a 5-well program? And I continue that. I say 100 trials, but we've recently looked at that and said, well, it needs to be closer to 1,000. But that's okay. When I'm done, I simply take whatever the tally is, 81, divided by the total, and that becomes my weighting factor for well number 8. If we had wells in here that were never selected, that means we shouldn't use that well to build our type well. So now that we've got this, how do we build a type well? That's the simple part. We simply multiply the history and